So in this video, I'm going to go through the quizzes on graphs of polynomial functions, section 5.5, just in case you missed something in class. So the first example was a cubic function, and again, the degree tells us how many times the curve changes direction. So if you count this as the first change, that's 1, and then 2, and then 3. Another way to think of it is if you find these humps, it's always going to be the number of humps plus 1. So there's 2 humps plus 1 would be degree 3. And then we can see the x-intercepts here at -1, 0, and 2. And so here's the equation for this function. And in order to find the x-intercepts, we're going to have to factor this. So the next slide shows the completely factored form, which is this one. And the way we do that is by looking at each one of these has a 2x in common. So we factor that out, and then what would we multiply 2x by to get 2x cubed? So that would be x squared. What would we multiply 2x by to get negative 2x squared? That would be minus x. And what would we have to multiply 2x by to get negative 4x? That'd be minus 2. Can you notice that's this option, but that's not fully factored. We can go one step further and factor this trinomial into a binomials. So x times x is x squared, and then two numbers that multiply to get -2 and add to get -1 would be -2 and +1. And this 2x has to stay on the front. Okay, and then from there we can see the x-intercepts. If we set this equal to 0, x minus 2 equals 0. Okay, what value of x would make this true? X equals 2. And then if we set the other factor, x plus 1 equal to 0, what value of x would make this true? It would be -1. Okay, and then this first factor also we have to set equal to 0. If we set 2x equal to 0, then what value of x would make this true? 0. 2 times 0 is 0. So that's why there are 3 x-intercepts. We can go back up to -1 and 0, to -1 and 0. That's how you find them, by factoring. Okay, the next one I did was a 4th degree polynomial. So again, we can see it changes direction 1, 2, 3, 4 times. And there are at most 4 x-intercepts. There don't have to be 4, but that's the maximum number there could be. Okay, and so this one, whenever you see 4 terms that are not like terms, we're going to use factor by grouping. So we want to sort of split this in half and ask, what do x to the 4th and 2x cubed have in common? And factor that out, so that's 2x cubed. Then we fill it in and we get x plus 2, because when we redistribute, we need to go back to this. And then the next grouping, what do those have in common? Would be they're both negative, so we can factor out a negative x. Okay, and then fill in the parentheses with x plus 2. Because when we redistribute, we'd get -x times x is -x squared, and -x times 2 is -2x. And now since these two are the same, we can rewrite this. We can rewrite it as x plus 2 once times these two, x cubed minus x. Okay, and that's this one, but this is still not completely factored yet, because this term, they still have something in common. They both have an x in common, so we factor that out. We get x squared minus 1. We still have x plus 2 here. Okay, and then this term still can be factored further. Notice that was this option, but this is not completely factored. This is not completely factored. Okay, x squared minus 1 is a difference of two squares, and so we can factor that as a product of binomials. So take the square root of x squared and you get x times x. Square root of 1 is 1, so we have plus or minus 1. And that's where all four x-intercepts come from. This one gives us 0. This one gives us the negative 1. This one gives us positive 1. This one gives us the negative 2. So those are the four x-intercepts. We can go back up and see where those are. 0, negative 1, 1, negative 2. Okay, the rest of the problems aren't quite so involved. What's the degree of this polynomial? So again, we're just going to trace. You can think of it in a couple of ways. Just trace, that's the first change, 1, 2, 3, 4. Or you can do the number of humps, 1, 2, 3, plus 1. Okay. So then we've got number 7. Which equation could be for the function in the diagram? Well, this is about noticing, again, the degree of this would be 3 because that's the first direction, second direction, third direction. So if the degree is 3, which one of these equations has a degree of 3? This is degree 5. This is degree 2. This highest exponent is a 4, so it's got to be this one. Okay, and then question 8. Again, same thing. Figure out the degree of this graph by tracing it. That's the first direction, second, third, fourth. So which one of these has the highest exponent? It being a 4 would be this one. Okay, and the next section was on x-intercepts. So we can, if we see a graph and we can see the x-intercepts, we can write out the equation by using the factors. So we always write this using the opposite signs. So this x-intercept of negative 1 corresponds with this factor in the middle, x plus 1. If the x-intercept is positive 1, then it corresponds with a factor of negative 1. If the x-intercept is x is 2, that corresponds with x minus 2. So it's always the opposite sign because these are where the y-coordinate is 0. So we're essentially setting this equal to 0 and solving what value of x would make this 0. Well, it'd be 1. This value would be negative 1 and this value would be 2. So that's why we have x-intercepts at 1, negative 1, and 2. Okay, so then another example where we can see if we've got an x-intercept at 0, that corresponds to just having an x. Because we could write this out x plus 0, but that's not necessary. And then this factor is going to give us x minus 1. This is going to be x minus 2, and this is going to give us x minus 3. So there's our equation. And I won't make you multiply all that out, if you're wondering, because we could distribute all of this out and get, I could ask you what the degree of this is. So you just 1, 2, 3, 4, or you can count the number of x's. 1, 2, 3, 4. That's going to give us x to the 4th once we multiply everything out. Okay, so next question, which equation matches the graph? So we just want to identify what the x-intercepts are. So let me get that, make that bigger. We can see the x-intercepts are at negative 2 and positive 1. So this one's going to give us a factor of x plus 2. This is going to give us a factor of x minus 1. Then we just multiply those together, and that would be this option right here. Okay, and we could multiply that out. We get a quadratic. The highest power would be 2. So this would be a degree 2 function. Okay, then question number 12, last one. Which equation matches the graph? So the x-intercepts are given. So if the x-intercept's -3, that's going to give us a factor of x plus 3. If the x-intercept's -1, that gives us a factor of x plus 1. If the x-intercept is 2, gives us a factor of x minus 2. So then we could multiply all that out, but it's not necessary. There's 3 x's, so this would be a degree 3. Changes directions once, twice, 3 times. Okay, so we're looking for this equation down here. X plus 3, x minus 2, x plus 1. Doesn't matter what order it's in. So there you go. Okay, last slide is just a summary. So, yeah, hope that helps, and thanks for watching.